So before I start with the new content, is there anything you want to ask about last week? Any questions? What did we look at? What did we look at last week? Yeah. So we looked at code that can be running on a server. And PHP is an example of a code that we can run on a server. We also looked at code we can run on another machine. Which machine was that? So code can run on the web server, but code can also run on another machine. So code can also run on the machine of the visitor to your website. It's a very different kind of code. So the server sends all the code to your machine, and it will then run on your machine, a bit like a locally installed application. Some things we can't do with code running on the client, on the visitor's web page. Let's say a website like Amazon, we couldn't run like that. How do users log on? Do we transfer all the articles and all the prices to the user? Yeah. And there are also examples where code is running on both machines and is talking to each other. So an example there we looked at was from Google Maps, for example. Okay, today I'm going to look in a bit more detail at PHP. PHP is the language our CMS will be using. PHP is also the language being used by Wikipedia, Facebook, and other websites. Okay. PHP, we talked about it last week, so I don't go into too much detail again. But it started in the 90s. And we looked at alternatives last week. We talked about what the alternatives were before PHP came along. And just to refresh your memory, how does it work if we visit a website with PHP running on it? It's the same as other server-side scripting languages. So our web browser, in this example here, will request a website from the server. If the file extension is .html, for example, the server will send the file straight back to the browser. But in our example, most servers are configured so that if the file extension is PHP, they will look into the file and they will look whether there's code in that file that needs to be run. You could basically call a HTML file .php. The server would just go into the file first. It wouldn't do any harm. You can't call a PHP file .html because then it will not work anymore. If you do that, the web server will just send the file to the visitor without checking for code. Okay, so we request a website, let's say specialoffer.php. The server will figure out, oh, this file has a file extension called .php. Let's look in the file whether there's any code, and the server will hand it over to the program that can read PHP code. All the code will run, and what usually happens is this PHP code will create some sort of output. And this output that will be generated by the PHP code will actually be an HTML file. So we are basically creating an HTML file there and then for this visitor, and it will then be sent to the visitor. And this PHP file might also talk to a database where information is being stored to retrieve information. So this is a common approach. So this page is created there and then for this visitor. And if somebody else goes there, or if somebody goes there 5 minutes later, this website that is being generated could look quite different. It could look the same, it could look quite different, depending on what kind of web page it is. If it's just something that doesn't change often, let's say the website for the, I don't know, Lancashire County Council, maybe it doesn't change that often. Maybe somebody else goes there 5 minutes later, it would look the same. But because code is running and the code will have lots of commands that will depend on all sorts of bits of information, it could look quite different. And here's an example how this could look quite different. Let's click on it. Yeah, here we are, Facebook. Who has a Facebook account? Yeah. So if I log on now, let's say for argument's sake, I have 150 friends, and this is PHP based, then the code will basically check my username and password in the database. We talked about that last week, how this works. And the code would then look in a table, who are my friends? And then it would look, what have my 150 friends written recently? And then it would give me the information. But if you log on, you might have 150 different friends to me. So if you log on, even though the code is the same, the PHP code will be the same, the web page you will see is quite different. This feeds back to what I mentioned last week, that these days PHP is often just some sort of interface for us to access information in a database. Any questions so far? Yeah.
So, like for me, the PHP code will be the same,
yeah.
but then a different website.
Yeah. Because it would go very different because I enter my username and password, you enter your username and password, and even though the code is the same, check username, check password, check who are the friends, what have the friends done last. And basically, our friends will be different. What our friends have done recently will be different. So even though the instructions are the same, I'm simplifying, but check username, check password, check friends, what have the friends done. Even though those 4 commands are the same, the output of those commands will be very different. Or a more simple example, which fits with the task you're supposed to do in the workshop today. Let's say you go to a website to convert different currencies. The code is the same, but there will be a database in the back end that will store what's the exchange rate pounds to dollars, what's the exchange rate pounds to euros, what's the exchange rate pounds to kwai, and so on. So the moment you basically pick a different currency, even though the code is the same, you will get some very different bits of information. So if you look for pounds to euro, what's that at the moment? 109 or something like that. What's dollars at the moment? So very often these days the PHP code is just an interface to the database. And when we work with content management systems, this is basically what we'll also be doing. You won't be touching the code. You're basically using a web interface to put more information in the database and to manage, for example, what permissions the users have. Okay. You've seen HTML last week. I just want to show you some PHP. You won't have to do any PHP coding, but basically the CMS you will install will be basically consisting of thousands and thousands of lines of PHP code. So within HTML, we basically try to hide PHP code in a tag so that it doesn't cause too much of a mess in case our server doesn't speak PHP and sends the file straight to the client. But basically we have this, I like to call it, island of PHP code in a sea of HTML. So we can basically here say, this is the start of PHP, we can put some commands in. a typical command here is echo. Echo will print something on the screen. So here echo 4 will basically print the number 4. Echo hello world will print hello world. We put it in quotes because it's a string, which means it's text. We can store values in variables. They start with a $sign. It all sounds quite complicated, but think about it. For example, you want to ask your user what currency they want to convert. And they say, I want to convert 50 pounds to euros. And then you've got to remember this 50 pounds. So this will be stored in a variable. That's kind of your short-term memory. So here's a very simple PHP script. What does line 1 do? Don't look up other modules. Now that you are here, you might as well pay attention to my module. So what does line 1 do? Yeah. Line 2? Yeah. Tricky question. Which line? I just put numbers there for convenience. They are not really in the file. In which line do we switch from HTML to PHP mode? Yeah, and where do we switch back? So basically in line 8 we say PHP is over now. And here's the command. Yeah, not very exciting. You know, this is still a static web page. It's not really dynamic, but it just gives you an example of how we can now mix HTML and PHP code. Let's click on the link. Yeah, and this is what we get. Yeah. So this is the PHP code, and the PHP code will create HTML output. Just here it's very simple. If you have a page like Wikipedia or Facebook, it's obviously orders of magnitude more complicated. So variables is where we can store a value. We can store letters, numbers, and more complex things I won't really go into because we don't really need it. So different variables can have different names. So have a guess? What's happening here?
It starts at 6.
Yeah, so PHP starts in line 6, ends in line 10. And what does the PHP code do? So in line 7, we are remembering a number, yeah. And we store it in $year. And in line 8, what do we remember? Yeah. So what do you think will line 9 do? Yeah, so what will happen here is $name will be replaced with the content of the variable. So what will the output look like? Any volunteers? Yeah? Okay, I took this code and I put it on our web server. Now the same way as you can put code on the web server. So let's click on it and let's see what the web server will do. Yeah. Exactly how you predicted. So the other thing we can see here is that basically once the PHP code finished running and has been converted into HTML output, we have no idea how that happened. Yeah? We just get the HTML file that is the output of the PHP file. We cannot see how it worked internally. Yeah? So from the code we can't see that Sherlock Holmes was actually a variable. The same way as if you look at the code for Amazon or Facebook or Wikipedia, you can't see the code that makes the page happen. Okay. We can change the value of a variable. So let's look at the PHP code again. Which lines is the PHP code in? 6 to 11, yeah. So line 7, what do we do? What's the name of the variable? The name of the variable is? 2 is the value of the variable. And what's the name of the variable? Number, yeah. So we say the variable called $number should have the value 2. So line 8, what do we see? Yeah. Line 9, what do we do? So now we say $number is 4, but we already stored a value in $number. So what's going to happen now? Do we get an error message like, oh, sorry, there's already something in there? Or there's already 2 in there, so we're going to put another 4 in, so we're going to have 6. What's going to happen?
Well, this just not saying number is now 2 again. Will it say that?
No, good guess, but no. So your assumption was there is already a value there, we don't let a new one in, so we just keep the old one. PHP could have been programmed to work like that, but it doesn't work like that. So the idea is if we tell the computer number is 4, then number is 4. You know, you are the god to your computer. And if you tell the computer that number is 4, then number is going to be 4. It just overrides it here. So again, I put this code on our server. Let's click on it. Yeah, here we are, as predicted. Yeah, this is out of the essence of making things simple, you know, because things are changing all the time. You know, let's say now somebody wants to convert 50 pounds to dollars, and then he wants to convert 80 pounds to euros. We just want to be able to easily override values. We can also here assign values. So here in this case we have an operator, which is the equal sign. We can do arithmetic, we can add numbers, subtract numbers, divide numbers, and so on. You can even multiply variables with each other. So this line, it will basically display num1 with 2 and num2 with 8. And basically this line of code will just write 16. So, you know, you can even do calculations directly with the content of a variable. You can also check for equivalence, or check is something bigger than, greater than, less than, and so on. The example I mentioned last week is you can program something like if the shopping basket value is greater than 20 pounds, then shipping cost is 0. And maybe if the shopping basket value is between 10 and 20 pounds, shipping cost is 5 pounds, and you know, and so on and so on. Any more questions about PHP? Okay, so our CMS will use PHP to talk to a database. So the code will never change. Yeah. You will install your CMS once. You'll have, I don't know, 5,000 files on the server with lots of PHP code. But actually the whole thing is just an interface to store information in the database. Everything will be stored in a database. Who has heard of database before? Yeah? Anybody here who has used Microsoft Access? That's a bit like a database. An easy way of imagining a database is to think of Excel, to think of spreadsheet tables. It works a bit like that. Now, within PHP or within any computer language, we can usually write information. We could write it as a file on the hard disk, but it would mean that there's a lot of things you have to do to manage the whole process. And we have established for many decades that a database is the way to go. Now there are different types of databases. Relational databases are those that have been around for a long time, and the idea is they're very precise. We put a value in, we get the same value out. Now recently, with big data and everything, we also have other databases that are not so precise, but they're very fast. Think of Google. Google supposedly knows all the websites on the open internet, so you can ask Google a question. You want to search for something. Google surely can't go through a list of every single website content in the whole world. That would take too long. So we have some special databases that can do some special tricks. They're not so precise, but they're very fast. But this is the traditional precise database. This is what we'll use, I don't know, when you put money in your bank account, your money will be held in a database like that. This is what our CMS will use. If there's time in the end, we can look at some examples of the other types of databases. So how does it work? Same old story. We ask the server for some file. The file is a PHP file. So the server will run the code, the PHP code. But now within that PHP code, so we've got an HTML file with PHP inside. And now within the PHP, we can put another language in, MySQL, to talk to the database. So now we are actually already mixing 3 different types of languages. So the server could then ask the database, for example, is the username and password correct? Or the server could ask the database, what is the exchange rate between pounds and euros today? Or things like that. The database will reply, and the PHP script can then take this response and can use this information when the website is being created. Going back to the Facebook example, it could be, who are your 150 friends and what have they done recently? Okay, so in the end, every major website these days is database driven. Maybe if you look at the website of your local chippy, maybe they don't use a database because it's just a browser, but usually everything is database driven. Let's do an example. Here's Amazon. Now it recommends some things for me. And if you go to Amazon, maybe it would recommend something else. Maybe it wouldn't recommend Playmobil and DIY tools. Maybe for you it would be Harry Potter books and Michael Jackson CDs or something like that. But it will be the same code running. It will just be basically feeding different information from the database. So the same code will come up with a different website. Or here a newspaper. All the different newspaper articles will be stored in a database. So if I go there, if I reload this page in an hour, maybe the main article has changed. I'll show you an example of a kind of kind of content management system like page. Yeah? So here's BBC News, and this is the home page. So somebody decided, so all the news articles will be stored in a database, and somebody has decided that this is the most important article at the moment. Yeah. Now if I click on World and Europe, look for World, this is also the most important article. For Europe, yeah, that's another most important article, and so on. Yeah. So all those different articles, they will be stored in a database table, and the system will basically then pull this information out of the database table and will present it on this web page. Okay, how? Right. So, if you want to imagine how a table looks like, excuse me, or if you want a graphical representation of a database table, it's a bit like this. It's a bit like a spreadsheet, yeah? With different columns. You can call them columns. The official database language is calling them fields, but if you call them columns, everybody will know what you mean. And here in this example, the official database language would call it a record, not a row. But if you call them columns and rows, everybody would know. So we have different entries here. This is supposed to be a student. So this is the username of the student. This is the date of birth, the department they're in, the first name and the surname. Now we need to make sure that we can uniquely identify a specific record. For example, if there are two John Smith at UCLan, and one got a first, and one got a 2-2, we don't want to be mixing them up. We need to be able to uniquely identify each record. Now theoretically you can do that by doing a combination of different attributes, by mixing different attributes together. As long as you can uniquely identify a record, that's good enough. In reality, because it makes things so much easier, we usually introduce a key which uniquely identifies each record. By creating an artificial key, it makes it easier for us to manage records. If you think of your student card, I don't know, your email address could be your key, or your student number could be your key, anything like that. But theoretically, it might be possible to uniquely identify you without that information. But because it makes things easier, we usually just use an artificially introduced key. The design is quite important, yeah? If you think you're a big website, something like Amazon, and you got millions and millions of requests every day, then if you design your database very poorly, then things might be 10% slower. But if you're Amazon and you've got 10,000 servers, then writing the code worse and it takes 10% longer, means it's the difference between you having to buy 10,000 servers or you having to buy 11,000 servers. So by writing your code more cleverly, you could have saved paying for 1,000 extra servers. Now these days, usually it's the other way around. Usually man hours are so expensive and hardware is so cheap that usually we don't mind anymore being inefficient. It was very different in the 80s or early 90s, when computer equipment was very expensive, memory was very expensive. Yeah, but these days computers generally are that fast that I think, unless something is really a super frequently used platform, like Facebook or Amazon or something like that, usually we don't care about optimizing the system, because usually we think it's more expensive to do it optimized, because we have to spend so much more hours paying the programmers than it is just to buy another server. Yeah, but here's an example. Imagine we have 100 students on this module, and let's say I'm ill or whatever, and somebody else is replacing me as the module leader. Then with this kind of design, we would have to basically change 100 different entries in this table. So normally we like to split tables into smaller tables. In this case, we would only have one line here where we say what's the module title and the module leader. But for our 100 students, we would have 100 entries here. We have 100 student names and they all study BT3023. If we want to change the module leader, for argument's sake, we only have to change it in one place, not in 100 places. Just a very quick overview. I don't want you to bother with it too much, because in the end you're not going to optimize database tables. Just want to give you a feel of what kind of thoughts are going into these systems. And in this example, there are different kinds of relationships here. For example, a module code, or a module, has one module leader. But a module has many students. So when we design tables, when we design the relationships between the different tables, we can design them like this. They're one-to-one relationships. Let's say, for argument's sake, in your organization, every user has one computer. There can be one-to-many relationships. For example, each department has many students, but each student belongs to one department. Or there can be many-to-many relationships. We usually don't like them, and we kind of try to split them up into two separate one-to-many relationships. That makes programming much easier. And because of this, we often even introduce artificial tables that stand between two tables that are connected with a many-to-many relationship, because it will just make everything much easier. So when you plan it, there are whole different ways of drawing this out on a sheet of paper for planning purposes. And PHP can talk to a database, and you've been given an email today, hopefully. And if you want to talk to a database from within PHP, you need to know the address of the server. In our case, it's BT3023 DB for server2.com. We need a database name and a username. Now, in your case, the database name and the username is the same. So for argument's sake, if your name is Arthur Dent, then your database name and your username is probably adentDB. DB stands for database. And a password. Now theoretically you can have many different databases available to you, and within each database you can have many different tables. But for our purposes, basically you only have one database. But in this one database you can have as many tables as you want. So once you connect to the database, once you've proven that you should have access, you prove it by providing your username and your password. You can retrieve records from the database, you can insert records into the table, and so on. So here's a typical example. This is a typical website selling a product, and basically everything on this web page is actually coming from a database. Look here, it's called product.php. Product ID is 21885, so the code will basically ask the database, what's the product 21885? And the database will then give you the name, the price, the stock levels, a description of the item. So every single thing you see on this web page comes from a database, And if I just put another product ID in, I'll just get a completely different item being displayed. So for us as the visitor of the web page, it looks like there are, I don't know, thousands of different pages with product details. But in reality, there's only one set of code. We hand over different product IDs, and depending on what product ID we hand over, this one piece of code will create lots of different looking pages, just according to the product ID. Your CMS is going to be the same. It will look like there are lots and lots of different pages, whereas in reality there's only one page with one code that pretends to be many different pages. Okay, since there's a little bit of time left, I'll just give you an example of this new type of asking a database. This new type of database that is very fast but not very precise. Yeah. So let's say if you want to store your grades in a database, you want to be sure the grade you store in the database is correct. Yeah. If you want to store your money in the database of the bank, we want to be sure it's correct. Now imagine you go to the cash machine and you just want to pick up 20 quid. So let's say you got 400 quid in your account. You go to the cash machine and you want to pick up 20 quid. Yeah. So you told the cash machine you want to have 20 quid. Imagine the cash machine calculates now how much money should there be in your account, how much money should it be. We take out 20 quid. Yeah. So it's the ID. So now we need to write this value back into the database, correct? Yeah. What if at that moment in time you just got your student loan paid in? Your student loan is 1,000. No? So suddenly somebody else thought 400 plus 1,000 is 1,400 and was putting that in the table. Yeah. But now, because your transaction hasn't completed yet, you're going to write the new value into the table. Yeah? New value overrides the old value. So you put the new value in, you wouldn't be very happy. Yeah. So there are all sorts of mechanisms built in for everything to be very precise. But we've got this other kind of database where we got to basically deal with huge numbers of data, and we've got to be fast, because fast is more important than precise. So example is searching the web. So if you've been on BT3023, you know this example already. But I want you to come up with an example of something. Think of something that I put into Google where you think there are not many hits. Yeah. Obviously, we're not going to put Manchester United in, because there's going to be lots of hits. Okay, give me an example of something where you expect lots of hits. What should I put into Google where there are going to be lots of hits?
YouTube.
YouTube?
Yeah.
Yeah. So there are 15,960,000,000 results for this query. Yeah. So good guess. YouTube is not a good thing to put in.
I thought you said a good thing.
Hmm?
I thought you said one with a lot of hits.
Yeah. No, I said yeah.
Right.
And now we do one with very few. So good guess. This one had lots of hits. Now think of something where there would be very few hits. Could be the name of your local chippy or whatever. Something where you think there shouldn't be many hits on the internet. My example would work with YouTube. but we probably need to spend another 200 years here for me to finish showing that example. But I can show this example very quickly. If you come up with something where you don't think there will be many hits. Yeah, so give me an example. Just brush the keyboard. Okay, the danger is we get zero. We get zero hits. Did not match any documents. So maybe something in between, billions of hits and no hits. Yeah. BT2201 students, ex-BT2201 students are also welcome to chip in.
Search for Matthias McCall.
For my name, I think that it's not that common a name, but I'm sure I'm not the only German with that name. 354,000 hits. By the way, that's not me. And that's not me either. Less than YouTube, yeah. That's me. Your logo takeaway if it is a funny name. Something very small.
Try 3 monkeys.
3 monkeys.
Oh yeah. No, but they're actually cool. That won't be a good one.
I'll put it in quotes. Nah.
Yeah, try Preston as well then.
1.2 million.
You're right, Preston. 3 monkeys, Preston.
Okay, I put it in quotes. That will make it. Okay, that's okay. That's okay. So by me putting it in quotes, I basically want these 3 words in exactly this order. Okay. So Google says there are 782 results, and it took Google 0.41 seconds to figure it out. Okay. So I go to the next page. So we need somebody who can be my computer. I've got a value I want to store in a variable. So who can remember this number for me?
782.
You're gonna remember it? Okay. So we go to the next page. Okay. Now we are on page 2, and there are 782 results. Let's go to page 3. What was the number?
782.
And what is it now?
25.
What happened? So this is the typical example where we don't care about being precise. We just care about being fast. Because if Google really wanted to run the question lies to all, they visit all the web pages in the world and they basically store a copy of the content on their own server. So there'll be billions and billions of web pages with the whole content stored. If they really wanted to search in their database table properly, it would take them a long time. Yeah, just to predict, to tell you how many results there are, they would have had to finish searching all the web pages. So this is one of those typical examples where we want to be fast but not precise. Yeah? So this is a new type of dealing with a database. This is not the type we are using. This is the big data type. Yeah, you want to quickly know what's going on. If you're a bit off, it doesn't matter. Yeah? So let's say Google asked 100 servers, and because the information can't all be stored on one computer, and when 90 out of those 100 servers reply, they're gonna stop looking because they think that's good enough. And you can see this is already pretty stupid by now. Well, GA is at Ghana, I'm not sure. But look, you can already see this is just one of those web pages that just wants to lure people in. And if you go there, you probably either get a virus or lots of advertising. Because here it says die Monkeys besten Menu. Then it says Bosch Bohrmaschine, eBay Kleinanzeigen, and other stuff. Christian Kicken, Lundquist, Instagram. Yeah, it doesn't make any sense. They just put lots of words together in the hope that somebody will click on it because they find it in Google. Well, now I'm curious. Let's have a go, but it's probably just advertising or a virus. Well, if the Yukon network is down this afternoon, you know where the virus came from. Oh, congratulations! I can win £1,000 Amazon gift card. Oh, I like that. Yes, okay. How often do you use Chrome? It even looks so official with the Chrome logo. I'm sure it's from Google itself. Okay. So there's a task for you to do. Let's close this down. Leave. Okay. Yeah, we got to move room. I'm just gonna show you first. In case you decide to work from home or something like that. Actually, are there new people already outside? Oh yeah. Okay, I'll show you in the other room. Not that they have to wait longer.